Okay, in this video we're going to look at how an electric motor works. We've got our DC power supply with leads. I've got a piece of copper wire inside a permanent magnetic field with the top marked north. This bit of wire right here is copper, so it's not attracted to the magnets in the permanent magnetic field, but when you put current through that piece of wire, Oersted says you will create a magnetic field. The magnetic field created in this piece of wire is either going to get attracted or repelled by the permanent magnet, and in this case it has two options. If it's repelled, we're going to say it gets pushed out. If it gets attracted, we're going to say that it gets pulled in. So it's kind of like an electromagnetic swing. It can either go in or go out. So we've got positive with positive, negative with negative, and here we go. Put the contact here, you'll see some sparks because it's a dead short, and we should notice that either it's going out or going in. Stop the swing. Try it again. In this case, we definitely notice that it's getting pulled in. That's an attractive force. And if we go here and switch these two contacts around, we've now reversed the current flowing through our piece of wire. We should notice the opposite effect. So now when I make contact, you can definitely see that it is getting pushed outwards. One more time. And now if we time it, we should be able to get this thing to turn into like a swing. And you can hear the power supply doesn't really like what we're doing, and they just shut the circuit breaker off. So we definitely have an electromagnetic force of interaction. It either gets pulled in, which is attractive, or pushed out, which is repulsion. And this is where the right-hand rule for a motor comes in. We can use that rule to determine which way the magnetic force will be applied. Okay, so the right-hand rule says place your fingers in the direction of the external magnetic field. Your thumb is going to point in the direction of conventional current flow, which is a positive current. The palm is going to face in the direction of the magnetic force, so that will tell us which way the wire is supposed to move. In the first case, we have the current is going towards us, the magnetic field is always going from north to south, and the magnetic force is going to be going in to the magnet. If we flip the current around, you can see the only thing that's different now is the current goes in the opposite direction, which means the magnetic force is going in the opposite direction and the wire is pushed outwards. So that is the right-hand rule for a motor. That is how we get a very simple movement of a piece of wire in a magnetic field using Oersted's principles.